We went over this for a whole semester, so we know about it. Sisyphus. The myth of Sisyphus. You all know the myth of Sisyphus, who was condemned to roll a rock up the hill, and every day or whatever it would roll back down, and so he spent his life, trying to roll this. And from a cybernetic perspective, we say the problem with Sisyphus was that he was working against the system. That the system was gravity and the rock, and the natural system is for it to roll down. So if you work against the system, it'll continually go back. So organizationally, if you try to make something happen in an organization that is not supported by the culture, the structure of the organization, you can push it and make it happen for as long as you hold it in place. But as soon as you let the pressure off, the organization goes back to what its natural system is. So that if you want to make organizational change, instead of trying to force things, you find a way to change the system. You look for leverage points, we say, where you change this, which changes that, which changes that, which changes the whole system. And then when you make that change, it rolls because the whole system has shifted. So it's a philosophy about how you make change that sticks in organizations versus, you've all had the experience of forcing someone to do something they didn't want to do, and as soon as you let go, they go back. So it's a point of a systemic issue. So let's do Shannon Weaver's source message receiver model. Who all has done this before? Okay, so not everyone has, so this is important for us to do. So Shannon and Weaver were people who worked for a phone company. They were trying to come up with a mathematical model for how we can calculate and guarantee that information would get from a sender to a receiver and over the phone lines or radio signals or whatever. So they made a model up to make sense of this. And they said, okay, you have a source that wants to send a message to a receiver. And that message has to be encoded and decoded. So the source puts the message in some form, writes it down, speaks it, talks into a telephone, does something so that that message can travel between one person and another person. And that has to take place through some kind of a channel. So there has to be a medium that carries the message. So in phones, the medium that carries the message is the wire, right? In radio, what carries the message? The radio, the carrier wave, it's called. The carrier wave carries the message. And so for instance, in a radio thing, you have a wave that is the carrier wave, and you modulate that wave. You take your voice signal, and your voice signal may look like this. You combine it with that, and you end up with a modulated wave that carries that wave goes out and travels, and then it hits a receiver and it's demodulated. That is, there are filters that pull out this wave and restore this wave, and you hear the voice come out of it. And so that's where the modem comes from. The word modem is to modulate and demodulate your computer signal. Because what it does is it translates. Your computer wants to send a message to, Yahoo or Google or something, Your computer is communicating digitally. What does it mean? I mean, the book makes a point of this, digital and analog. So what's digital information?
Yeah, it's zeros and ones.
Zero and one is discrete bits of information. So digital is discrete, on, off, burst, no burst. So Morse code is digital. Yeah, so it's digital. Analog is continuous. So like when I speak, I'm making an analog sound wave. It's not chop, 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 chop. It's continuous. So what your modem does in your computer is it takes the information that your computer wants to send, it turns it from a digital form into an analog form. Because the phone wires want analog information. So it shoots the analog information over your phone lines to wherever it gets, and then the modem on the other computer demodulates it back into digital form, and then that computer can understand it. So you can understand why this theory has a lot of technicality in its hard form. Now, when we talk about the soft forms of it, like Peter Senge does about learning organizations and teamwork, you're not really into this so much. But you can see from the article you read that some people can really use this to think about the processing capacity of the human mind and the memory storage allocations that go on. You use this as a metaphor for understanding human communication. Machine communication, human communication. So we talk about that. All right, so you have your source, your message that goes across a channel. It's modulated or encoded, it's decoded or demodulated. And there's also the problem of noise, which is interference, or, AM radio gets a lot more interference than FM radio because lightning makes AM waves and stuff. So all this kind of stuff. So you have noise, and we talk about that in our field, about psychological noise, cultural noise, interpersonal conflict noise, all kinds of things that prevent information from being received in an unequivocal, unambiguous way. It's very little use from a computer perspective for the Google to sort of get part of your message, right? That's not going to work. Google's not going to be able to deal with the fact that it got 4 out of the 6 letters you typed. It needs the information. And so there are ways in which computers build in redundancies and checks for making sure that the information sent was all received. And there are protocols for this. And I don't know all of those protocols, but I think part of it is that there's one part of the stream of information is a count of how many ones and zeros should be in this message, right? And so it gets that, and then it counts the stuff that comes through, and if there's something missing, it knows it didn't get all the information. So there's a redundancy check about it. So you have noise, and then you also have feedback, which means that the message gets sent the other way to check it. So I say, let's go out for dinner tonight, and you say, do you mean tonight or do you mean tomorrow night? So I send a message, you hear the message, and then you give me feedback to clarify what the message was. And then I say, I meant tonight. So that becomes a complete double interact, what we call a double interact. Message sent, message received, feedback received, and then another message sent. 1, 2, 3. It's a double interact. I interact with you, you interacted with me, and then we're clarified. So that's a very important concept, because often in interpersonal we study this, right? We study what you said and then what they said back. But in cybernetics, we think a lot of the interesting things come in that next moment, because this gives us a lot of information about what was going on here. So we think in terms of double interact, not just one interact, but a double interact. 1, 2. So, all right, so this is the Shannon-Weaver model of communication. Now, when you think of feedback, what's your concept of feedback? What do you...
In human interaction, that would be what somebody's critical evaluation is.
All right, so we look for, I did a play, I acted a play, and what's that?
Yeah, right.
Yeah, right, that's way out of I acted a play, in a play, and I sent a message out. I sent information from a cybernetic, I was a sender, you're a receiver, I'm sending a message through the medium, the channel of the costuming and the words and the lighting and all these things. I send a message, and then you receive that, and then you send me some feedback that says, here's what I saw, here's what I heard, or this is what I think about it. And then you then say, you're an idiot, you know, you don't know it. You give the rest of the interact that tells how you've received or whether they have accurately done that. I mean, that's a hard example, but right. But the idea is that if a unit, a sending unit, operates without feedback, it has no ability to adapt to its environment. It has no ability to learn. Learning is doing something and getting feedback.
I was just thinking, within the same. Let's go back to the theater metaphor. Actually, when I thought about it, when you said it, the first thing I thought of is after rehearsal, you get feedback from your director, and then you make an adjustment based on that feedback. And then sometimes he has to make an adjustment because, every now and then they'll go, no, wait a minute, think of it this way. And we'll go, oh, that's right, that is funny. Leave it in.
Right, so the in terms of the Navy gunship thing, the sensor, detects what's going on. It sends a message to change this, do this differently. And then someone may be watching, or it may learn. This is where this whole idea of neural networks and machines that learn, computers that learn, it may detect then, oh, well, when I did this, it went too far. So now I'll do it less. So it may learn new rules in its feedback, right? And that's a whole interesting field these days. Can we teach? So robots too, they teach them to learn. So you make this robot thing and you turn it on and it goes and bumps into things, and then it has the ability to rebuild its rules according to what's happening. And so then you didn't have to program it, it learned by itself how to navigate. So it's interesting stuff. Joe?
There's just a question I've been having since reading the chapters in general. There's one thing that was said. It said that one of the things that cybernetics does is it looks at the system as a whole as opposed to certain parts within the systems.
Yes.
And I was wondering if you could just explain that real quick.
Right. So let's do that simply. The simplest way is to do it with a family. A, B, and C. So here's 3 people in a family. Okay? Parents and a child. We'll take. Now, one way to look at the child's behavior is psychologically. We can say that, this child does these things because of this psychology to them. That they think this way, they have these attitudes, they have these traits and tendencies. So that's why that explains their behavior. Systems theory says you cannot explain the behavior of this unit without taking into account the complex interrelationships that exist between this unit and these other units. So that this child's behavior is a function of all kinds of complicated relationships with parents, with friends, with family. It's not as if this unit just existed in an isolated form and went about doing its stuff based on internal messages. It is functioning on the basis of complex relationships and the way the father talks to the child, and the way the mother talks to the child, and the way the mother and father talk to each other, and the way the mother and father together talk to the child. All of those things are part of the explanation. So to explain the behavior of any individual part, you must step back and ask, what system is this part embedded in, and how do all of these complex interactions affect the behavior of this part? So maybe that gets at it a little bit.
Yeah.
Okay. Yeah. So when I do organizational analysis, this is a good example. When I do organizational analyses and I'm watching a team that's not functioning well, and I talk to people in the team and they say, you know what our problem is Bill. Bill's a jerk. Bill, doesn't do anything. Bill's the problem. If we could get rid of Bill, we'd be fine here. And that's a kind of a psychological approach to it. A systems approach says Bill's behavior is a result of a number of things about how you're relating to Bill, how you and this other person relate to each other, and then in turn how you two relate to Bill, how Bill relates to this person. It's all intertwined. Because you could take Bill out of this group and put him in with a different group of people where his behavior would change. Because people treat him differently, people interact with him differently, there's a different set of rules, and there's a different set of needs. And so all of a sudden, he's a hero. He's performing admirably. Well, what did Bill change? No, what changed was the system and the relationships that Bill was dealing with. So that's part of the idea that, so I'll get into arguments with psychologically oriented people that say, well, that's a really nice idea, and so you tell everyone, learn new ways of interacting and behaving that will change. And as you change your behavior, that will cause a cascade of effects that eventually Bill will probably change his behavior too. So the solution to your problem is remote from where you've identified the problem. You think, here's the problem, we'll deal with it here. Systems theory says the solution to this problem may be 4 connections away. And that if you deal with this, that'll affect this, that'll affect this, that'll affect this, and then that'll change. So we say that in systems theory, we look for a point of leverage. We look for a point where if we change this, I change that, I change that, I change that, I change that, and now that thing that we were worried about is changed. And nature works this way. This is the way nature works. The mosquitoes feed the frogs, which are eaten by the rats, which feed the cow, or however that works. And so if you have a problem, say with mosquitoes, and you think, oh well, we'll just kill all the mosquitoes. Well, you've just changed a system. And so now all of a sudden, all your cows are dying because you killed all the mosquitoes. And you're like, well, how's that work? That doesn't make any sense. Well, it makes sense when you realize all the interconnectedness of things. And so before you solve your problem, you better think about all of the systemic issues, all of the connections and relationships that exist. So when we talk about systems, we see things not as a collection. A family is not a collection of people. Like you might have a car collection where you have this car and that car and this car. They're all in the same place, but they are not interacting. And they're not interacting in complex ways. They're just there. So family is not just a collection of people. As soon as you put people together, they start to interact. They start to form relationships. They start to form rules about how they're going to relate. So you put 2 people together and they start doing that. Put 3 people together, and all of a sudden it gets more complicated. In the ABC system, you've got how A relates to B. You've got how B relates to C. You've got how C relates to A. You've got how A and B relate to C. when A and B are together. You've got how B and C relate to A, and you've got how A and C relate to B. So all of a sudden you've got a huge number. So in 3 people, you've got 6 different rules and relationships going on. Now, I mean, you add another person, and so you put 8 people together in a team. How many relationships exist there? Just a huge number.
It just came to me now. Could it be the comparison between the sum and the combination in mathematics? Because it's kind of the same thing.
Yeah, so that would be right. This is combinatorics. Yeah, combinations. Right. All the possible permutations, right, and combinations of these elements, because sometimes the mother and father relate as a unit to the child, and sometimes the mother and the child relate as a unit to the father. And so that's a different kind of relationship and sometimes the father and the child are against the mother. Oh, your mother's unreasonable, she's asking you to do that. So you have all of these permutations and changes. And systems theory says you can't just think about this person. You've got to talk about this, you've got to talk about all of this. So you've got to ask questions about, and how does this input from this create an output in the child or the person or the team member or whatever it is? And how do all these messages being exchanged, what do they all do in the end in terms of control? Or what is the goal? See, this becomes a question. What is the goal of the system? Right? The goal of a thermostat is to regulate the temperature, maintain the temperature. The goal of the naval gun control system is to shoot down the enemy plane. What's your body's goal? All right, your body's goal is to be healthy, so you have an immune system that fights off diseases. If you get cold, your body tells you so your body shivers, right? Your body shivers. It increases its metabolism to warm itself up. So your body is a feedback system with sensors, inputs and outputs. And it wants to stay at 98.6, what is it? I forget. 98.6. If you get too hot, your body sweats. So your body is set up as a self-regulating, goal-seeking organism. Right? It regulates itself. It has loops. When it gets to the right temperature, it stops sweating. And it's a goal-seeking organism. It has certain things it wants to accomplish. So systems theory asks the question, what is the goal that is organizing this body of relationships? This family. What is the goal of the family? That will explain a bit how it's regulating itself through its inputs and outputs in order to maintain something. So Melissa used the word that we talk about, it's the homeostasis. Same to stand in the same place, to be stability. And so one of the things that general systems theory says is that in nature and in life and in natural systems like the earth and birds and everything is built around this idea of stability. Every system, if you push it this way, it wants to go back. If you push it this way, it wants to get back. It tries to, if you put the rock up the hill, it wants to come back down the hill. Everything wants to go somewhere. It has an end. Sometimes we talk about the end, the purpose of a system. What is the purpose of a system? One of the other ways to think about that is, we talked today about organizational DNA. Have you ever heard that? People talk about organizational DNA. And what do they mean by that?
They're just programmed from the get-go to accomplish this thing.
Right. So that you put anything into it, and the organization will use that to create something. And like you take your body, you eat anything and it turns it into you. Right? I mean, you can eat this, or you can eat that, or you can eat this, whatever. Your DNA turns it into you. Doesn't make us different, So it takes whatever resources come in and uses them to maintain something. So this is where organizational DNA comes in. So you say, well, we've been doing this, but now we want to do this. We've been producing this in this way, but now we want to function this way. We want to achieve a different output. Well, you can try to force everybody to do that, but that's going to be hard because there's already a DNA. There's already patterns and systems and things that people are used to doing, they're comfortable doing, they want to keep doing. So you push them over here, and that's against the DNA of the system. That's against the organizing principle of the system. So it's not going to work well, and as soon as you take the pressure off, it'll go back to what its DNA is, what its organizing principle, what its purpose is. And this idea of autopoiesis is the idea that systems will naturally figure out how to function to do that. That they will organize themselves to do it. To achieve their ends. Whatever the end is, the system will push itself into a structure that will do that. So this is organizationally, from an organizational theory perspective, this is a very different organizational theory perspective. Because one of the articles was talking about Max Weber and rationalizing organizations. So in Max Weber's view, organizations will function efficiently and effectively when they are structured rationally. So what we do is we say we want to achieve this end, and so that means we need this structure. These people need to do this, and this one needs to report to this one, and here's our structure. And when everybody does what they're supposed to do and reports to the one and this control comes from here and it flows down to here, and then the control flows down to here, and the control, all of these don't think, they just do what the control tells them to do, then we will efficiently and effectively produce the output we want in this organization. That's called rationalizing the organization. Not like rationalizing your behavior, why did you do that? But applying rationality, rationalizing the organization. So this is the consultant who comes in and says, oh, you're all disorganized around here. You need some structure. You need an organizational chart. You need to know who to report to and where information flows from. That's that model. Now, people who work in these organizations, rationalized organizations, quickly discover a couple of things. One of the things they discover is that things never work this way. Right? I don't know if you've ever worked in a situation like this, but the formal structure is highly different from the informal structure. There's a formal structure to the organization that says if this person wants to know something, they talk to this person who talks to this person, who then at a weekly board meeting talks to this person. But that's the way it's supposed to work. The way it really works is this person lives down the street from this person. And so when they want to know something, they go talk to this person who talks to this person who talks to this person who then talks to this person. There are human relationships, there are other connections, there are natural affinities between people that change the way things work. The system, but the system knows that it's got to produce this. So at the end of the day, everyone kind of creates a structure that gets that done, but it gets it done in a way that may be quite different from the rational structure. So for instance, I had a friend who worked for ADP, the payroll people, and he used to tell a story of, in ADP they had this whole chart about stuff, who reports to who, and he says they used to just throw that away, and they would just make the things happen. They would call the people they knew from conferences. They had people they